You're looking at problems from sections 3.1, 3.2, and 3.3 on these pages. This is for our class on the 26th of February. These problems, this assignment is due on 5 March. Alright, we'll begin with page 182, number 1. This set of problems is asking us to graph ordered pairs. I feel fairly confident that you know how to graph ordered pairs, but we will look at a couple. A says -2, -1. Well, it's x, then y. The x number is left and right, and the y number, coordinate we say, is up and down. The x movement is horizontal, the y movement is vertical. Thus, the first point, -2, -1, 2, is 1 to the left and then 2 up. This point would be -1, 2. B says -1, -2. That would be 1 left and 2 down. -1, -2. You can see they have the same x value, thus they are the same distance horizontally from our origin. 5, 0 is C. 5, 0 would be there. Alright, with that information, see if you can then graph the rest of those points. Next we will look at 5A. Alright, it says which of the following tables could be produced from the equation y equals 2x minus 6. We're given y equals 2x minus 6. And if you look, each one of the tables have the same independent values. That is, the same x, the same domain, and it is 0, 1, 2, and 3. We want to know what the corresponding y values, the dependent values, the range values are for these independents. So we'll simply take these values and substitute them in. Substituting 0 for x. Y equals 2 times 0 minus 6. Y equals 2 times 0 is 0, minus 6 is -6. Thus, when x is 0, y is -6. 0 pairs with -6. Alright, let's look at another value. Let's substitute 1 now. 1 in place of x. So we previously had y equals 2x subtract 6. Substituting 1 in place of x, y equals 2 times 1 minus 6. 2 times 1 is 2 minus 6, so y is -4. When x is 1, y is -4. This next one I will do in my head. Substituting 2 in place of x. 2 times 2 is 4, minus 6 is -2. Notice the pattern here. As x is increasing by 1, these y values are increasing by 2. That's because the multiplier by the x. This is the slope. This is the rate of change of y per x. So for every 1 our x increases, our y will increase by this multiplier here. Alright, thus 3 will pair with 0, and 5a therefore is B. 5a is B. Alright, next 7a. Which graph shown here is the graph of the following equation? And they give us a line. That line crosses our, this is the y-axis, it crosses our y-axis at a value of -2. 0, -2. It crosses over our x-axis at a value of 3. 3, 0. So if we look at this line, didn't do such a good job of hitting that other point. Just increase the size of it a little bit. Looking at this line, which of these equations will it produce? Well, from our class notes, we know about slope-intercept form. Slope-intercept form. Slope-intercept form is the form y equals mx plus b, where m is the slope and b is the y-intercept. So, in this particular problem, we see that the y-intercept is -2. Thus, the equation for this line is going to be y equals some number for slope. I don't know yet, but I do know this y-intercept is going to be -2. Alright, now I just need to find what this slope is. Well, we discussed in class, slope was a rate of change. Slope equals the change in y divided by the change in x. Well, we can simply draw ourselves a right triangle between these 2 points. Our change in x in this case is 3. It goes 3 units to the right. Our change in y is 2. It goes 2 units up. Thus our slope, change in y over change in x, is 2 over 3. And this value will go in place of m. Okay, so the equation of this line is y equals 2/3 x minus 2. And that is selection B. Alright. Last one from this section, we're going to look at problem number 15. Number 15. It says, find the intercepts for the graph, then use them to sketch the graph. We're given the equation y equals x squared minus 9. Well, hopefully you remember that when it's squared, when we have an x squared, this will produce a parabola. Thus, we're going to oftentimes have 2 x-intercepts. Alright, let's investigate a couple of values. I'm going to substitute a 0 in place of x. When x is 0, 0 squared is 0, showing the substitution. 0 squared is 0, minus 9 is -9. When x is 0, y is -9. This value is my y-intercept. At the intercepts, one of the coordinates is equal to 0. Well, as it happens, we will have 2 different x-intercepts. 3 will pair with 0 and -3 will pair with 0. Let me show you that in this case. Substituting 3 in place of x. So we have y equals 3 squared minus 9. 3 times 3 is 9, minus 9 is 0. So you see when x becomes 3, y becomes 0. Likewise, y equals, substituting -3. -3 quantity squared is 9. 9 minus 9 is 0. When x is -3, y is 0. So these are my intercepts, and I could use these values to then sketch my parabola. I have the value 0 pairs with -9, perhaps that's here. 0, -9. 3 pairs with 0, 3 with 0, and -3 with 0. Alright, and this would be the parabola for y equals x squared minus 9. So, in summary, remember, at the intercepts, one of the coordinates, one coordinate is 0. Thus, we can take 0 and substitute for x and find the y-intercept, or substitute 0 for y and find the x-intercept. Alright, continuing on our assignment, we are now looking at page 201 and 202. We will first look at problem number 2. You don't have to do problem number 2, but the odd problems that you do have to do will be very similar. Problem number 2 states, for each of the relations, give the domain and range and indicate whether it is a function. Alright, so number 2 gives us the set of ordered pairs, 2 pairs with 1, 4 pairs with 3, 6 pairs with 5, and 8 pairs with 7. Alright, the first thing I'm going to do is write this in a table. X and Y. Well, my X values are 2, 4, 6, and 8. 2, 4, 6, and 8. My Y values are 1, 3, 5, and 7. 1, 3, 5, and 7. Well, it asks us to list the domain and range. The domain is the set of X values. This is my domain. Domain. 2, 4, 6, and 8. One way we would write it is D colon 2, 4, 6, and 8. Alright, that is my domain. To simply circle these and say that's domain, that would be a reasonable way to write it. These values are the range. The range is the set of outputs, the set of Y's range. We might say that the range is the set 1, 3, 5, and 7. Okay. Alright, now it asks us to say whether or not this is a function. Well, a function is a relation where each input goes to only one output. So yes, this is a function because 2 only pairs with 1, 4 only pairs with 3, 6 only pairs with 5, 8 only pairs with 7. I told you to remember the phrase no confused x's. No confused x's. Right? Indeed, none of these x values are confused. They know exactly where they're going. If 8 was also pairing with 5 in addition to 7, it would not be a function. Okay, so this relation is a function because each input, the x's, pair with only one output. That is the y's. I need the comma there. Alright, that's number 2. Next we'll look at number 10. Number 10 says, state whether each of the following graphs represent a function. Well, in class we talked about the vertical line test. Vertical line test. If we draw a vertical line through a graph and it touches more than once, it is not a function. Thus, we're looking at, I'm going to show problems 10 and 16. Number 10 and separately number 16. Alright, number 10 shows us what appears to be a parabola. And number 16 shows what might be considered a sideways looking parabola. Well, we haven't discussed any parabolas that look like this, but in fact neither of these show arrows extending, so I'm going to just terminate this right here and this one as well. These points, they simply stop there. Alright, so using our vertical line test, any place we draw a vertical line through this graph, we will only touch the graph one time. Thus, this relation is a function. Okay? Any place we draw a vertical line, it would only hit one time. But this relation here is not a function. If I drew a vertical line through the graph at any of these points, I would hit 2. For instance, right here, drawing a vertical line. We would strike this graph at this point, which might be, say, 2, 1, and we would strike the graph at this point, which might be 2, -1. And as you can see, this value 2 is repeated. 2 is pairing with 1 and 2 is pairing with -1. Thus, number 16 is not a function. It is a relation, alright, but 2 is pairing with 2 different values. 2 is confused, we might say. 2 is pairing with 1 and 2 is pairing with -1. Thus, number 16 is not a function. Alright, one last one. Problem number 20. Determine the domain and range of the functions. Assume the entire function is shown. So number 20, I'm simply going to look at the book here. Alright, the domain is the possible x values. So if I bounded this graph on both the left and the right, we would see that we go from -2 to 2. The domain on number 20 is from -2 to 2, including those endpoints. The range, it's bounded at the bottom at -3 and at the top +3. So my range is from -3 to +3. And I would write that in this fashion. Number 20, the domain is from -2 to 2. And the range is from -3 to 3. Notice that range is the y, the output, domain is x, the input. Alright, that'll conclude this video. To see page 218, view the next video.